Welcome back, everybody. In the last video, we learned that the atmosphere gets heated from the bottom up because the Earth takes in sunlight and turns it into heat, which then gets released back up. We also saw that there are gases in our atmosphere called greenhouse gases that trap that heat in. Well, what is it about those gases that actually trap heat? And why do we even care about it? Well, that's what we're going to discuss in today's video.
The Earth and the Moon are basically the same distance from the Sun, yet temperatures on the Moon average an unlivable -18 degrees Celsius, regularly exceeding both the coldest and hottest temperatures ever recorded on Earth. What protects us is our atmosphere. By day, it serves as a shield, blocking out the most harmful and energetic of the Sun's rays and about 1/3 of the less intense but visible light. At the same time, it traps the infrared radiation, aka heat, radiating out from Earth's sun-warmed surface, keeping us from freezing solid at night. In order for our atmosphere to absorb any kind of radiation, it needs to have some electrically charged particles for passing electromagnetic waves to push around. And most of our atmosphere is made up of gas molecules that don't have an electric charge. They all have a balanced number of positive protons and negative electrons. But some molecules hold most of their negatively charged electrons closer to one side, lending them a lopsidedness that can jiggle back and forth to absorb the energy of incoming infrared rays. For example, water, ozone, and nitrous oxide are all electrically lopsided, so they all absorb infrared radiation. Then there are gases like carbon dioxide and methane. On paper, neither molecule looks lopsided, so it doesn't seem like they should be able to absorb any radiating heat. But in reality, gas molecules aren't motionless. They crash into each other billions of times per second, knocking each other in different directions and also into different modes of rotation and vibration. And it turns out that both carbon dioxide and methane spend most of their time shaking it in electrically lopsided ways, allowing them to absorb infrared rays and help insulate the Earth. Even though many different kinds of molecules can absorb infrared radiation, the vast majority of our atmosphere can't, because it's made of nitrogen and oxygen, which don't get lopsided even when they are vibrating. They're too symmetric. Nevertheless, the lopsided 1% are such good infrared absorbers that they manage to intercept about 90% of Earth's outgoing heat. Each captured ray gets pinged around the atmosphere, and most end up returning to the surface at least once before escaping to space.
I want you to find this page in your notes entitled The Greenhouse Effect Continued. In the last unit, we learned that the atmosphere is made of mostly nitrogen and oxygen. All the greenhouse gases in the atmosphere actually make up a very small percentage of the total atmosphere, so in order for them to be able to trap in so much heat, there must be something special about them. So like we just saw in the last clip, nitrogen and oxygen are actually smaller and simple molecules. Their symmetrical shape keeps them from trapping heat. Greenhouse gases, on the other hand, are bigger, more complex molecules. Their electrical charge makes them lopsided and not symmetrical. This makes them better at trapping heat, or infrared energy, because that energy moves in bigger wavelengths. Makes it easier to catch. So if greenhouse gases only make up a small part of our atmosphere, why are they such a big deal? Let's look at some pros and cons of greenhouse gases. The good thing about them is that they keep us warm. Without greenhouse gases in our atmosphere, we wouldn't be able to survive on Earth. It would be way too cold. On the other hand, if there's too many of them, they're going to trap in too much heat and it'll get too hot. And that's the problem that we're having today. So if there's too few of them, it gets too cold. If there's too many of them, it gets too hot. So you can see we really need to have just the right amount of them in our atmosphere to have the kind of temperatures that we need to survive on Earth. So why are there more greenhouse gases in the atmosphere today? Let's see what National Geographic has to say about it.
Human activities, from pollution to overpopulation, are driving up the Earth's temperature and fundamentally changing the world around us. The more greenhouse gases in the atmosphere, the more heat gets trapped, strengthening the greenhouse effect and increasing the Earth's temperature. Human activities, like the burning of fossil fuels, have increased the amount of CO2 in the atmosphere by more than 1/3 since the Industrial Revolution. The rapid increase in greenhouse gases in the atmosphere has warmed the planet at an alarming rate. While Earth's climate has fluctuated in the past, atmospheric carbon dioxide hasn't reached today's levels in hundreds of thousands of years. Forests cover about 30% of the planet, and the ecosystems they create play an essential role in supporting life on Earth. But deforestation is clearing Earth's forests on a massive scale, and at the current rate of destruction, the world's rainforests could completely disappear within 100 years. Why should we care about deforestation? Deforestation impacts the amount of greenhouse gases in the atmosphere in two ways. First, when trees are felled, they release the carbon they are storing into the atmosphere. Second, trees play a critical role in absorbing the greenhouse gases that fuel global warming. Fewer forests mean larger amounts of greenhouse gases entering the atmosphere, and increased speed and severity of global warming. The effects of deforestation are grave, but not irreversible. Efforts such as managing forest resources, eliminating clear-cutting, and planting new trees to replace those removed are already being made to reduce deforestation's environmental impact on our planet.
So why are there more greenhouse gases in the atmosphere? For starters, the burning of fossil fuels, such as coal, oil, and natural gas, releases them into the atmosphere. Deforestation, or the cutting down of large areas of forests, means less of them are removed from the atmosphere. There actually are many other factors contributing to the increase of greenhouse gases in the atmosphere and to climate change in general. But ultimately what's happening is that human activity is causing an imbalance in something called the carbon cycle, which is something we're going to get into more next time. More carbon is taken from other parts of the Earth and accumulates in the atmosphere.